Hello. So now I'm gonna give you a short introduction about electric vehicle to gym simulator. At first, I would like to tell you what EV2Gym is. As you can see here, EV2Gym is a simulator where we are simulating how electric vehicles can be charged uh, in time. So at first, we have the configuration state where we can decide what is the electric vehicle and charger specifications. Maybe we want to select the charging topology. When I say topology, I don't mean the distribution grid, I just mean how the chargers are connected to which transformers. Next, we can also select the EV behavior, like when the EV spawn or not. We're using some open source data for this right now. Also, we have the charging prices, which right now we're using the day ahead price. If the gym doesn't have a market mechanism at the moment, doesn't implement a spot market. So if you want to do this, if you want to implement such a mechanism, you need to do it. Um, yeah, and then scenario selection, yes, this is another parameter. So when we start, the environment can look something like this. Chargers, electric vehicles come and go, and in every step we are called to decide how much to charge every car. So we're giving an input, which is the charging current, because so yes, we're giving the charging current. However, because we are using reinforcement learning, we want to have values bound between 0, 1 or minus 1 to 1. And this is why the actions represent how much we're charging. So if the action is 0, it means it's not charged. If the action is 1, charged at full power. If the action is minus 1, this charged at maximum power. Alright, so I have implemented a few baseline algorithms, like I'm going to show you later, such as optimal, using the Groby framework, some heuristics like round robin as fast as possible, and model predictive control, here again using the Groby framework. So for this model predictive control methods I have implemented is about deciding the optimal charging schedule again. So we assume the prices are fixed and we're trying to optimize the charging schedule of the electric vehicle based on that. And then what I mostly care about, reinforcement learning, where in order to do reinforcement learning easy, you need to implement a gym API. What is a gym API? You can check this place here, gymnasium. It says very nicely how this works. But to give you an idea is that you have a reset function where you reset the environment, your simulator, and then you're taking an action by calling this step function. So you put here your actions like 0, 1, whatever, and you get an observation, the new state, a reward, and some other variable like terminated, truncated, and info. By doing that, then we can try and use any type of RL algorithm available online in GitHub. So by implementing this gymnasium API, we can use any algorithm we want. So it's very easy for us to test new algorithms. Right, and something important I want to say is that at the end of the simulation, we're generating a replay file that includes all information about when it is spawned, prices, loads, everything. So we can we can replay this specific simulation with maybe another algorithm and then compare them, see which algorithm is the best. Right, so this is the overview. Here you can see there is a small description. This is how a snapshot of the simulator can look like. Chargers, we see that some current goes there, goes to the cars, then every car has a state of charge, and all this current can be aggregated in a transformer level. Then we have the aggregator charge point operator where is monitoring everything, and the total load is aggregated over there. This is how a configuration file looks like. However, I believe it's quite intuitive. I will not go into detail. It has some comments already. Um, Something else, right now we have some inflexible loads and solar power. Um, Load curves, they're based on open source data from the Pecan Street dataset, and these are just some parameters that we can use to amplify how high these loads can be or how low with respect to the transformer power limit. And this here is the file structure. So the idea is that when we go to the EV2Gym folder, or actually I can show you, I want to show you the class diagram first. So we have one class, one EV2Gym environment class, and then we're generating many transformer classes, where every transformer has some variables. Let's see how a transformer can look like. So EV2Gym, modules, transform. So every model I have created has some class variables like maximum power, inflexible load curve, solar power curve. So by having these member variables, then we can do other things that I will see later actually. Right. So we have one EV2D environment object, and then we are creating many transformer objects, many chargers, and any NEVs can spawn there. They come and go. And then we have the data, which are usually CSVs and NumPy files. Then we have the baselines, which are different algorithms. And then we have some other helping scripts like evaluator. We can compare multiple algorithms there. We have the train RL, where I show how you can use stable baselines, which is a library to train reinforcement learning algorithms. Then we have the utilities functions, which loaders help us load all the data into the simulator, such as EV behavior, when EVs arrive and depart, price, etc. And utils, just some helping functions. Then we have the visuals, like how we want to visualize some things in the end. So we also have that. And another important thing for reinforcement learning, the state and the reward. And where we have to decide how the state looks like and how the reward looks like. All right, so let's go see an example first, how an example looks like. So this is the example.py that you can find in the root folder of the project. You see we're importing several algorithms, etc. First thing we're doing is, what we could do is we can load as a specific simulation from a replay, but let's say at first we don't have any replay, so replay path equals no. We're selecting a specific configuration file, let's say this one, and then we are creating an EV2Gym simulator instance. First things we're doing is we're resetting the simulator, and then we can just run it. Here I'm selecting a very simple strategy that starts as fast as possible, which always tries to start the cars as fast as possible, giving them the maximum power. And in the end, we have some stats. So these are metrics that we are monitoring in the course of the simulation that help us understand how well the algorithms are performing. Here again, we have let's say another algorithm, the power tracking error minimum, which is the mathematical programming algorithm that tries to solve a deterministic problem, which means we have already simulated a replay, we know what's going to happen, and then we say, okay, given this specific scenario, what is the optimal solution for this problem? And this is what this do for a specific object. All right, so we have seen the example.py. Let's go see the main classes. Like I said earlier, here you can find all the different classes. In Groby models, we have the mathematical programming method. In MPC, we have in the MPC folder, we have the model predictive control implementation and heuristics, the heuristics one. You will see we have no reinforcement learning implementations because we're using the stable baseline. So the only thing we need to do for reinforcement learning is go to the RL agent, and then define the state, reward, and cost functions. These are functions that are called from the main EV2Gym environment class and are returning a specific reward based on metrics. For example, let's go to this one, profit max, transform penalty, user incentives. For every step, we're getting all the costs, the charging costs, and we're putting as reward. Then we're adding some penalty terms. For example, whether we overload the transformers or not. And in the case that NEV is departing, we are also adding the user satisfaction as a penalty. So the user can select or create their own reward function. Similarly, the user can select or create their own state function. So what is a state function? State function shows some information about every step. For example, for this public power set point tracking problem, we are returning information about the time of the specific step, what is the set point. Then for every charger, for every electric vehicle connect, we can return information about whether it's fully charged or not, total energy charged, or other things. We are free to make our own assumptions here. In EV2Gym, we're monitoring every possible variable. For example, EV2Gym knows what is the state of charge of every electric vehicle, but maybe an aggregator might not know what is the state of charge of every EV. So we are not going to return it here then. So yes, we can create our own function. The cost has to do with another thing. It has to do with safe reinforcement learning, but this is another concept we're not gonna cover today. Next on, so we've seen this data includes all the data we're using. All of these are open source data. None of this is private. This file over here has the prices. Like we mentioned earlier, these are day-ahead prices. In practice, day-ahead prices are very similar to dynamic prices, or let's say they have the similar relations. This is why we're using them. However, in practice, you might want to use other prices. I'm going to show you how to include them later on. Example config files here. We have a few different scenarios what we can select from, but also feel free to create your own. And then we'll go to the most important folder, the folder with all the models we have created. Like I said earlier, we briefly saw the transformer model, but of course there are other ones. There is the electric vehicle model that has some variables like desired capacity, battery capacity, other things, max AC charging power, minimum. So we have a lot of different configurations here. We also have the charger. So the charger also has some variables here you can check. The grid is not implemented yet. This is just a template we're going to implement in the future, where we're going to add also the grid. So this is a template, doesn't have any functionality. And then we have the replay class that is saving the state of a simulation, so we can load it again another time and replay it with another algorithm. But let's see the base class, the class that everything comes from and everything runs from. This is the EV2Gym and class. Here, let's see what are the important functions. The important variables here is the configuration file, because based on that we're loading the simulation. However, sometimes we can choose to have a replay, so we can also put a replay path and then try to save to replay the same game again and again. You can also decide the state function, the reward function, and pretty much, yeah, these are the most important ones you need to decide. The first thing that happens in the init function is we are loading things. For example, let's see what happens with prices. We're going to, here we're setting up a lot of different variables. Here we are loading EV charger profiles, load transformers. All of this is functionality included in the loaders. So let's see how the loaders look like. In the loaders we have a few different functions. For example, load EV profiles. So here we're loading some specific, actually we're generating the EV schedules for the whole simulations at first based on some distributions. Um, you can check the EV spawner function for more details, but uh, I'm not gonna get into more details now. About electricity prices, it's very simple. We're just reading this CSV, and we are creating two arrays, a charge price and discharge prices, based on this data, based on when the simulation happens, because the simulation has a date. So this is how we create this thing. If we want to replace this price, maybe we can replace the functionality of this function here and load our own price. All these loader functions we can see here are called from the EV2Gym EV2Gym environment during the initialization. So here it's important to, here we are loading everything, every information. And the second function we implement here is the reset function. The reset function, let's go down here, can be called so the simulator returns back to state 0. And how does the simulator steps? How does it go to the next state? Well, it's this one here. In every step, in order to go to from one step to the next, we have to call the step function, and we have to give some actions here. Here, action is a vector of size. Let's say we have a simulation with 10 chargers, 1 port each, then the actions should be a vector with 10 values, with values from -1 to 1. And what we're doing here, we're iterating over all the chargers, and we're calling the step function of the individual charger. So if we go to the charger, we will see that the EV charger model has its own reset and step function, where the step function, when it's called, we're putting as into the actions, also the charge and discharge prices, because this info is placed here in the main function. So we're putting the actions, which is how much we want to charge, and then we're iterating over all the electric vehicles that are connected. So then we're calling the EV action, and then the EV is updating their own battery capacity in every step. Anyway, I'm not gonna go into more detail now. So we're iterating over all the charging stations. We're updating the EVs connected in the end, and we are returning some things. For example, we're returning how much it costed to charge or how much money we gained because we sold energy back to the grid. If an EV has departed, then we are returning the user satisfaction metric, which shows how much we charge the car and if we were close to what the user wanted. This is also a metric that we can change. This is not something we are implementing, and basically, yeah, these first two things. These are useful because in the end of the step function, we are calling let's find it. Okay, we go to check the termination over here. We're not terminating, of course, and then we're calling the get observation. So we're calling this function that gives us the state. Then we're calculating the reward. The reward is obtained by here, this function, the calculate reward. Calculate reward is calling the function we have created in the RL agent over here. So here we're calling these functions. So yeah, this is the main functionality of EV2Gym. It iterates until the end of the simulation in every step. You see here the example. We're basically iterating until the simulation finishes. And in the end we can get some stats, and yeah, that's it. If we, let's say, we want to do reinforcement learning, then it's very easy. We just need to follow this example. We're creating a EV2Gym environment like this. We are defining the reward and the state function we want to use. And then we select an algorithm like the DPG. In this case, we say learn, and then everything happens, and in the end we can evaluate. I believe this is most of the things that EV2Gym does. Of course, there are a lot of more details that you can check the paper for more details, or you can send me an email and ask me some questions. Of course, if you find any problem, feel free to raise an issue here, and I will try to see if something doesn't work as intended. Thank you a lot.